If you've ever written a line of code, you know the feeling. That moment when an error message flashes, the program dies, and you're just left staring at the screen. But what if one of the oldest, most frustrating crashes in computing history isn't actually a mistake at all?
Yes. For any programmer, this one is an old friend, the Stack Overflow. It feels like this ghost in the machine, right? A bug that has been haunting us for decades. You'd think, with all the power and all the memory we have now, we would have solved this thing already.
And that's the real mystery we're going to unpack here. Why is this thing, this relic from the absolute dawn of computing, still capable of bringing our most advanced software to a dead stop? Well, it turns out the answer is that we've been asking the wrong question all along.
Okay, let's get right into it. To really understand why the Stack Overflow is so stubborn, we have to get our words right. Are we actually dealing with a bug, or is it something else, something deeper?
Now this is where it gets really important. We all know what a bug is, right? It's a mistake, a typo in the code you can just go in and fix. And a limitation, well, that's just a physical reality, like your hard drive being full. But a design flaw, that's a totally different beast. That's an inability that was intentionally built into the system's DNA because of a choice someone made a long, long time ago.
And that, right there, is the core idea. The Stack Overflow crash, it's not an accident, it's not a typo, and it's not because you just need more RAM. It is a direct, predictable, and believe it or not, necessary result of how we decided to build our computers in the very first place.
So to see why, we need to hop in a time machine. We're going way back to the early days of programming, when the blueprints for modern computing were just being drawn up.
So back in the late 50s and early 60s, computer scientists came up with this brilliant way to manage how programs work. It's called the call stack. The easiest way to think about it is like a stack of plates. When a function needs to do a job, it puts a plate on top of the stack. If that job needs to call another function to help, it puts another plate on top of that. When a job is done, it takes its plate off, and the program knows exactly what it was doing before. It's a super clean, really orderly way to keep track of everything.
And they chose this design for some incredibly good reasons. A stack is blazing fast. It's predictable. It's safe. It prevents a whole bunch of really messy memory problems. For the people building the first programming languages, it was just this elegant, simple solution that worked perfectly for almost every problem they could imagine.
Okay, now here's the kicker. The people who designed this system, they knew it had a weakness. They knew that if a function just kept calling itself over and over and over again in an infinite loop, what's called unbounded recursion, it would eventually run out of space on the stack and the whole thing would crash. This was not an oversight. It was a known, accepted trade-off. Which, of course, brings us to the big question. If we've known about this for over 70 years, why can't our modern technology just, fix it? Well, let's take a look at why all the common solutions don't actually solve a thing.
The first idea everyone has is the most obvious one. Just throw more memory at it. The stack is too small, just make it bigger. Problem solved, right?
Well, no, that doesn't actually work. A bigger stack just means the crash takes a little bit longer to happen. You could have a stack the size of a planet, but a program with an infinite loop is still, infinite. It will always fill it eventually. You're just delaying the inevitable, not removing the flaw. The boundary is still there.
Okay, fine. So more hardware isn't the answer. But what about smarter software? Programmers have all these clever tricks up their sleeves, like something called tail call optimization. Surely that's a fix.
And this is what's so fascinating. This technique fixes the problem by secretly rewriting the code. It turns the problematic, self-calling structure into a simple, flat loop. It works by avoiding the flaw entirely. So instead of proving the flaw can be fixed, this workaround is actually one of the strongest pieces of evidence that the flaw is real and unavoidable. You can't solve it, you can only sidestep it.
I mean, just think about that number. The fact that this bug has survived for over 70 years through these astronomical leaps in computing power and memory, that's the ultimate proof. If it were a simple bug, we would have squashed it decades ago. Its persistence tells us it's part of the very fabric of our machines.
So, if it's not a bug and we can't fix it, then what is it? This is where the whole story pivots from a technical problem to something much more profound. The Stack Overflow isn't just a glitch, it's a message from the machine to us about a hard limit of computation itself.
You see, our computers are built on a bedrock of linear logic. A causes B, which then causes C. It's a straight line. But unbounded recursion creates a circle. A needs B, which needs C, which loops back and needs A again. The stack, by its very design, can't handle a circle, so it tries to unroll that circle into an infinitely long straight line, and that's when it runs out of road.
Now, this connects to one of the most famous, most mind-bending ideas in all of computer science, the halting problem. It's a mathematical proof that says you simply cannot write a program that can look at any other program and know for sure if it will eventually stop or just run forever. It's fundamentally unknowable. And here's the beautiful, mind-blowing connection. A Stack Overflow is the halting problem coming to life. It is the physical moment where a machine, unable to predict its own infinite loop, hits a boundary it cannot cross and is forced to stop. It's the theoretical limit made real.
So the crash isn't the system failing. It's the system being perfectly, brutally honest. It's the machine's way of saying, the logic you fed me is circular, but my entire design is linear. I cannot represent this. I'm done. It's an honest declaration of its own limits.
Once you see it that way, it really reframes everything, doesn't it? This unkillable bug isn't a problem we need to solve. It's a feature that defines what our computers are, and, just as importantly, what they are not.
Our computers are what you'd call mechanisms. They follow a fixed set of external rules. They're predictable, they're deterministic, they are not entities, like you or me or any living thing, which are defined by constant, internal, self-regulating feedback loops. The Stack Overflow is the firewall that separates those two worlds.
And that right there is the grand bargain. This design flaw is the price we pay for all the things that make computers so unbelievably useful. We get perfect determinism, verifiability, predictability, and simplicity. And in exchange, we gave up the ability for the machine to truly handle self-reference.
Which leaves us with one last, really big question to chew on. The Stack Overflow clearly shows us the boundary of our current way of computing. So it makes you wonder, what kinds of problems are waiting for us on the other side of that boundary? What will it take to build a computer that doesn't have this flaw, and what new worlds will that unlock?